Hello folks, in this video I'm going to show you how to configure Modbus TCP communication between an ABB AC500 PLC and a Schneider Altivar 650 VSD. I am going to be using a 22 kilowatt Altivar 650 VSD. So we start by assigning an IP address to the embedded Ethernet card on the VSD. So we go to communication, we go to embedded Ethernet config. You can configure the device name, you can pick and choose whether you want to use a fixed IP address or you have a DHCP server that assigns IP addresses to your device. So in my case, I'm going to use a fixed IP address, and I'm going to put my VSD on the .10 range. So I'm going to give it an IP address of 192.168.10.10. So I will also configure the subnet mask to be 255.255.255. So that is about all that I need on the IP address assignment. So having done that, the next thing that I need to do is to assign an IP address on my the computer's NIC card so that I can be able to communicate with the VSD, so that my PC is on the same network as my VSD. So to do that, I start by pinging my VSD. So it's not replying. So that means they are on different networks, or it cannot see my VSD. So I assign an IP address. And in this case, I want my computer to be on the .10 range, and I'm going to give it an address of .10.250. Pinging again. Now we see that my VSD is replying now. So the next thing that we need to do is to configure the VSD for Modbus TCP communication, and we're going to use SOMove software. So I open my SOMove software. So we go to edit connection or scan, and we put a range, the range that our VSD is in. So remember, our VSD has an IP address of 192.168.10.10. So we put a range that has that IP address inside of it. So already you can see that my software can actually see my VSD. Okay, but you can do a scan. So put a range .10.1 up to 12. Then we scan. So you see, it already could see my VSD there. So I connect to the VSD, but it asks me for a password. So how do you find the password for the embedded Ethernet card? So you go to communication COM parameters, you go to embedded Ethernet configuration, and you scroll down to use authentication. Scroll down again to default password for the embedded Ethernet card. So that's the IP, that's the password, that's the default password that we need to put there. So we put in that default password. So it asks you to whether or not you want to change the password. Yeah, well, we'll do it later, so we can just cancel and continue. Okay, so it gives you some warnings, and so you can say I've read that and I understand the risks involved and stuff. So we connect to the VSD. So as you can see, the device is synchronized. So we go to parameter list, and on parameter list you see that on the Simply Start there are all those parameters like motor frequency, the nominal motor power, and so on, that you can configure there. But we want to go to command and reference, and there are three important parameters that we need to configure. So that's FR1, CHCF, and CD1. So FR1, which is the configuration reference frequency, so we put embedded Ethernet there. And on the control mode configuration, we put IO mode there, put IO mode. And then on the command channel assignment, we're going to use Ethernet. We're not using the terminal block, we're using Ethernet on that one. So those are the three parameters that you need to change there. And then we go to field bus. On the menu, on the navigation there, go to field bus and then protocol and drive profiles. So on there, it gives it tells you the registers that are already that come default, but this is where you can add registers if you need to be reading from certain registers in the drive. For example, you might want to know the voltage, you might want to know the power, you might want to know the torque. So for as long as you know the short code, you can add the short code there. So by right clicking, you can right click and say add, and then you type in the short code and then you select it. So these are the registers that I would like to use. Motor frequency, motor current, motor voltage, those are what I want to read. And then in terms of what I want to write, I'll just leave the default, which is the command and the speed set point. So after configuration, we can disconnect from the device and then store the configuration to the drive. But it asks for a password again, so we put the password and we connect we store to the device and connect. So by doing this, we have configured the drive for Modbus TCP communication. So the drive is ready now for Modbus TCP communication. Now we go to the PLC side configuration. So on the PLC, we can go to interfaces and Ethernet and go down to protocols. So we select the protocol. So the protocol that we want to use is Modbus TCP. So our PLC is going to be the Modbus TCP client. and the device, the VSD, is going to be the server. So the client is going to be requesting certain information from the server, and the server gives it that information, or it's going to give commands to the server. So okay, so now for the Modbus TCP communication, we're going to use a standard library function block, ETHX modmast. ETHX modmast. So this is the standard function block that we're going to use for Modbus TCP communication. So the function block has got inputs and outputs. So the enable, the ETH, IP address, unit ID, are all inputs on the function block. And to understand what these inputs are or what they mean, we can consult the help. So the help explains what each input is all about. So as you can see, that's the help, and that's the function block that we're going to use. And on the documentation there, it has input descriptions and output descriptions, and the function call in structured text language. So the enable, for example, that's the input that has to be driven in edge triggered mode. That's the enable. So that enables that block. So whenever it becomes high, it enables that block. So all of the inputs are explained in there. And the outputs as well, they are explained. That done there, it indicates the state of the job processing, and then there is the error and the error number as well. So everything is explained in the documentation there. But then for the enable, which we have spoken about just now, we need pulses there. So every time we need to communicate, we need a pulse. So those timers are going to ensure that we have pulses there. So I've already configured the writing to the VSD using that function block. So what we are going to write to the VSD is the command register and the reference frequency. So that's the CMD register and the LFR registers. And we're going to read those registers: motor voltage, motor power, motor current, motor frequency, motor torque. We are going to read all of that from the VSD. So for each of those registers that we're going to read, we have a function block for that, and we have the address as we got it from SOMOV, the address of the logical address of the particular function. So what we are going to read from the VSD and what we are writing, I have created arrays of unsigned integers. So there's the read array and the write array. And then we have those timers for the communication trigger. Let's go online with the PLC so that we can see whether we are communicating with our VSD, whether the connection is okay with our VSD. So those are the pulses, the 100 millisecond pulses that I'm getting from them. So as you can see on the function block, there are no errors that I'm getting there. So that means my communication is sound. My communication to the VSD is sound. I'm not getting any errors. The done is coming out as true each time I get a pulse. So if we're going to go to the array, the read array, you can see that already the first register in that array, you have that number 568 there. So you can see that the status, because that register is for the drive status. So you can see that we are already reading the drive status, and we are reading the STOX digital digital inputs there. So our communication is sound, our communication is okay. So now we're going to attempt to change the speed reference, or to give a speed reference to our VSD. So as you can see on that array, the first register is the run command. The second one is for the speed reference. So if I put 1500 there, which corresponds to 50 Hertz, we can put that value there, and you see immediately that my drive has actually taken up that speed reference. If I change it to 750, which is 25 Hertz, and enter that, you see my VSD is getting that. So the first register of the array, the right array, is the one for starting the drive. So as you can see, so if I put 11 there so that I can start it, you can see that already it's in run mode. You can see that it's in run mode, it's running, my VSD is running. And if I'm to stop it, if I put a 0 there, if I'm to stop it, you can see it's decelerating. And now it's ready, it has stopped. So this is how you would test the communication, how you would run your VSD from the PLC.